And you can also have this set up. I don't know if you bought chucks for like a milling machine or a surface grinder, so you can take the electrode out of the milling machine and go right over to the EDM machine with the orientation. And the orientation is right, and it's straight. Like I was trying to show them that this is not a finished surface. Mm-hmm. That's a cast surface. So now when I use these set screws to hold this electrode holder in there, that electrode could be anywhere, you know, this way. Mm-hmm. So a couple things you can do to fix that is to grind this surface or mill that mm-hmm. surface, you know, and do it on a chuck in a milling machine. And again, I think he's probably got a chuck that he bought for a milling machine, and you can put it on a surface grinder as well. But anyways, you have a drawbar, which is difficult to move out. It basically goes into the back of the holder. It goes into the back of the holder, and then you turn it like 45 degrees because there's a ledge right underneath here that these flanges go underneath. A little difficult to do. Once you get it under there, you can snap this plastic ring down. Okay. And now we can put it in the machine. You have hence the name 3R, 3 references. You have your Y reference, you have your X reference, and you have your Z reference. The pads are here for the Z, if you notice, and then there's some pads right here that fit into the slots of the holder right here for the X and the Y. So it goes up, and then over here, you just tighten it down, and now the holder is in there tight. Okay, so that's the little spiel on the tooling. Any questions on that? Like I said, he's got to have more of this tooling somewhere. This is probably what the chuck actually came in this box. So it was put up on the head here. All right, so we're going to start right at turning the machine on. And what you have to make sure is that, first of all, you have your circuit breaker is turned on here.
This is called a circuit breaker.
Yeah.
Okay, that's great.
So it's on the on position. You have your emergency stop turned out, so it's not. That's how you turn the machine off if you need to turn the machine off.
You don't need to go through a shutdown routine.
Well, you should probably. I'll show you that in a minute.
Okay,
I got to turn the machine on to shut it off.
Yeah.
When you're all said and done, you could just hit the emergency stop after you do a shutdown. Yes.
Okay.
And then you're going to fire the machine up with the green button right here. Okay. One thing you're going to notice right away is that there's a voltmeter. The voltmeter was at 0. I should have pointed that out. And now there's 25 volts on the machine right now. And that's the potential difference between the head and the table. That's important because when you move the machine around and also locating the part with the electrode, you are going to use the potential difference of positive to negative to find surfaces. And also, it will allow you not to crash the machine. So if you're jogging the machine around and you're jogging an electrode and it hits something, as long as it's electrically conductive, it will stop. If you're moving at the rapid rate, the collision protection will allow it to stop so you don't damage anything on the machine, but you might break an electrode.
Fair enough.
So the first thing that comes up is your machine setup page, and that's, by the way, that red button up there is how you shut the machine down. Totally. You know, that red, if you hit the red, it's like a shutdown on XP or something. But it tells me right away that it needs to have an execute an XYZ axis home. So it needs to be brought home, first of all. All right? Any questions so far? So, let's go over the axes of the machine first of all. You have your X-axis. I'll say okay to that. By the way, it's a touch screen. If I didn't already make myself clear there, but it's so right now we're on the machine setup page, but you can move through the pages by hitting what they call the modules up here. So as I'm doing that, it's moving through each module. But right now we're concerned with the machine setup page. This is your hand pendant, but we were going over the axes. X is moving the machine this way, X positive is that way, X negative is this way. Program the electrode, because the table is actually moving the opposite direction. What I mean is if I move now, see how the table is going this way, the electrode that way, that's X positive. Okay, when the electrode moves that way, that's X positive. When it moves this way, X negative. Y is moving the electrode in and out. Y positive would be going away from me. Y negative is coming towards me. And then finally you have the Z axis to move up and down. Z positive moves the electrode up. And Z negative moves the electrode down. So what I'm going to do now is show you I'm going to show you the collision prevention that's built into the machine.
So the voltage went to zero.
Good point. It gives you a couple indications here, okay? The voltmeter that was at 20, 25 goes down to 0. And it also gives me a little alarm. If you see it at the bottom of the screen here, it says a short circuit was detected while jogging or positioning. I can't move the machine now, so I'm trying to move it. The Z's not going anywhere. I can't touch the screen. So, to get out of the collision, very important, very, very, very important, is I need to turn the collision off. It's that button right there. It's the blue button right there. When I do that, think in your head, which way do I want to go? Because if you go the wrong way, you'll smash the electrode. All right, so I want to go Z positive. Z positive. So, and by the way, if you do this, there's your speeds down here, how fast you're going. Slow, medium, and fast. All right, so right now I'm in the medium mode, so maybe you just go slow in this time, right? So if I hit that button right now, it's in the slow mode. I hit this button, and I go Z positive. And the Z, I pointed to the wrong axis, but the Z did move up, okay? And I'm out of that. How do I know I'm out of the collision? That voltmeter is back up. So I'm not in a short anymore. Any questions on that? That's important because you don't want to break things. You don't want to break electrodes and stuff like that.
So the warning is still there.
Oh, yeah.
Yeah, I mean, it'll show that, you know.
If you reset that or
Yeah, you can.
Do we also have collisions in the X and the Y directions?
Yes, all axes have collision prevention
Oh,
built
got it.
into it. Yes. Yep.
Just do it in the same way.
I'm sorry.
If you want to remove the collisions, just do it in the same way as you
Right,
did first.
right.
Yeah.
Just make sure that you know, like I said, X positive is that way, X negative is this way. Just make sure you know which way you want the electrode to move off if you are in a collision.
How do you clear there?
You can hit clear right here at the top. So it shows the last one though on the bottom. Still will show the last one on the bottom, but. All right, so the first thing that it asked when we fired the machine up was what? It needs to be home, right? So, by the way, this is how you shut the door. Pull up on that. This is for a little pin that goes through right here on the door, so you can't, when the machine's full of oil, you can't come over and hit that and have the oil spill on the floor on you. So again, on the machine setup, the first thing that we're going to have to do if the machine has been turned off and then turned back on again is to home it. So I'm going to hit the home icon here. You see the home icon right there? When I do that, it's going to change. It's going to say over here, Z positive, Y positive, X positive. The safe thing to do is to do the Z first. So to do it, I just click on or touch Z positive. And then on my hand pendant right here is my cycle start. That's cycle start, that's cycle stop. So if I cycle start it, it's going up right now. It goes up in the Z. If I wanted to stop it, cycle stop. Any function that you're doing, you can stop in the middle if you needed to. So we're going to do the Z first.
Did you press up on the Z or does it automatically?
No, it goes on. All I had to do was hit the cycle start. That's all I had to do. It will tell you when it's done. First of all, you notice this over here? It was turning when I was doing the function. Well, it stopped, and it also said, now it says Z is at the reference point. So now I want to do Y or X, and then hit the cycle start.
And the door needs to be closed while this is all happening.
Although they might have changed that. We'll see.
It's already in the reference point, so.
Yeah, but I don't see the switch here anymore. They used to have a switch on the door. We'll see. So we're going to do the X. Nope. They changed that. There used to be a switch, right? So you had to have the door closed. I'm not sure I like that, actually, but.
So is this a switch right here?
Huh. Yeah, but it's still going.
Oh yeah, I know,
function.
but maybe it wouldn't let it.
Well, it's not going to let it fill the tank.
Right.
Right.
It's just gonna have some sort of switch.
But that switch used to not allow you to even do one of these functions, you know, with the door open. Right, so you need to do that if you shut the machine off and turn it back on again. Everybody okay with that? All right, so what we're going to do now is move over to the piece and find the top of it with an edge find function. So again, I can do that going over the modes down here. If I now move my x-axis over, see how slowly it's going? It's because I'm in the slow mode right now. So I'm going to go fast with it. It's not really that fast, but it's the fastest this machine can go. It's not like a milk machine. So what I'm going to do is get it close. And by the way, I could zero out the display. So if I wanted to zero out the display right now, I just click on it and say 0 and say OK. The reason I'm doing this is to show you this function right here, the step function. So that if I click on that step function right now, so it's lit up, and I hit X, for instance, all right, so if I go lower, I'm moving a tenth at a time. And if I go with the by the way, you can choose these. I'll show you a little bit later on the configuration of the machine. Going into the user settings. Like right now it's in inch. I don't know if you want to work in inch or you want to work in metric. It doesn't matter to me. We can change on the fly by going to the configuration of the machine. But that's what the step function is for, is to move it in increments. So if you had to move it a little bit over at a time, you'd go into the step mode. Okay? So that's what you know what that is. This has no, some of these features are used on the wire EDM machine. This is the same pendant that's used on the wire EDM that's used on the sinker EDM machine. So some of these have no bearing on what you're doing here. So the ones I don't refer to, don't worry about. This would be if you had an automatic chuck, air actuated chuck. Instead of using that to hold that drawbar into the chuck, that's what these two are for, opening the chuck and then closing the chuck. So those mean nothing to you either right there. All these over here have to do with like return. You want to back out of the cut right there. Go ahead, I'm sorry.
I was just going to ask, X, Y, and Z in the step mode, are they the same distances?
Yes. Yep. By the way, you do not have a C-axis. That would be another axis. Well, maybe you do have a C. No, you don't. It's not even on the C. That's wrong. That would be for rotating the electrode. If you needed to do a constant rotation of the electrode or indexing the electrode, that's an option on the machine, so you don't have that. So don't worry about that button either right there. Okay, so what we're going to do now is we're going to do an edge find. And I'm going to ask for a victim from the audience to try this. Rather me hitting buttons, people learn more by when they hit the buttons. So on this page right here, the setup page, you're going to find an icon on that screen that says Edge Find. So you're going to hit it. No. I'm not doing it. Yep. And what happens is you notice that you have a new page open up here on the right hand side, and it gives you an axis and a direction that you want to go in to edge find. And what you're doing is you're trying to find, in this case, the top of that part. So you want the Z to go negative. Correct? This distance right here is about 1 millimeter, right? And that's how far it's going to, after it hits the top of that part, it'll be in a short. You want to get away from the short. How far back up is it going to go when it's done with the function? Okay, it's a default of 1 millimeter, 39 and 4. It's only to relieve the short. Okay? The speed, you see the speed down below there. Why they do this, I don't know, but the speeds are from 1 to 10, and actually 10 is the slowest. So they got it at 9, which is a pretty slow speed. They should really have it at the opposite way, but you know, that's okay. It says preset the axis. In other words, when it finds hits the top of the part, it's going to set the Z to that number right there. It's going to set the Z to absolute 0. So you can program from that spot. So we don't necessarily need to change anything over there. However, if you wanted to, you could. For instance, if you're not edge finding on 0, say you had to edge find above 0 somewhere, you know, for whatever reason, you couldn't edge find on the point that you wanted to call 0, you're edge finding 100 thousandths above it. Then you could put in the preset of 100 thousandths. But for the most part, you're going to keep these things the same over here. So really, we're ready to go. If you hit the green button on the hand pendant for the cycle start, you will notice that the Z will come down and do it. Right? Yep. Now watch the Z's coming down. And if you look in there, it's going to hit. And if you notice, the voltmeter will probably move a little bit. See it? See it? It's finding that edge. It does it a couple times. Sets a 0, and then backs up to 39 4/10. So it was touching that edge a couple of times to find what it thought was the 0. Then it backed up the 1 millimeter. So that's how you establish the top of the part, okay? Because when we go on to the next page, where we actually program in the burn, it will be from this 0 spot. Okay? All right, so the next thing you could do, you could do it like you could move the electrode over and find an edge, or in this case, what I want you to do is to take this electrode and find the outside of this part. Which means you're going to position the electrode about in the center of that block by eye, right? So we need to move the Y with that in the negative direction a slight amount right now.
I literally just pressed.
Yep. So what I'm trying to do is get the electrode, because you're a millimeter off the top of that, so you should be fine, right? Just trying to get the electrode somewhere kind of in the middle of that shape right there. You know what I'm saying? Yep, go that, yep. Keep going.
So are you stepping or?
No, she's
I'm in medium.
she's
Oh,
scared.
All right.
You don't have to be perfect with it because we're going to actually use the machine to find the center of this. We just want to get it close by eye before we do this. That's good now.
The
Yep.
X is pretty.
Well, we're not going to do the X. We're going to just do the Y because we really can't go over. And what I'm going to do is we're here. I'm going to tell the machine to go over, drop down, find that edge, come up, come to the other side, find that edge, split the difference, and come to the center. Okay? So we can't do that in the X because we got these clamps in the way. So we're just going to do it in the Y. Okay? So the other icon right now, you're on the edge find icon. I want you to go to the center find external. And you notice another window popping up, right? This shows you to do the X. This is kind of showing you, although it's not a great icon, it's showing you the Y. So you want to do the Y. So you'll light it up. And when you did that, by the way, you see how these are gray right now? When you light them up, now they're able to take information. So what it's looking for in this window right here is an amount to move over, safe distance to move over, and then to come down and edge find. So what we need to do is get a scale, or by eye say, all right, that piece is about at, I don't know, 700 thousandths thick. The electrode's a little bit bigger than that, say 900. So that's 1 inch, we'll say 1 inch 750, right? You add up the electrode, you add up the piece, and you add up a little bit of safety in there. Because it's got to move over a certain amount. Well, it's got to move over half the electrode, half the piece. Plus, you're not sure if you're in the center or not, so you got to move a little bit more than that. So you put in the total amount. You don't put in half. The machine divides it in half. So just for safety purposes, I want you to put in there, I don't know, 2.2. So you just put your, yep, and the keypad, yep. Say okay. Good. Good. So, again, there's your speed. There's your 0 axis. What that means is, when it's clicked, when it gets done with the function, the Y will be set to 0. You follow the Y dimension or the Y coordinate. So it'll go over, it'll do what it's supposed to do, come back to the center, and set that position as Y0. Y absolute 0. Okay? No? Yes? Everybody kind of understand that? All right. But we need to tell it from where we are right now, 39 thousandths, 1 millimeter, how far down. We've told it with this number to go half of that amount, 1.1. It needs to know how far to go down to edge find. So it's got to go at least 1 millimeter, because it's from where it is right now. I put in there, I don't want to go down too far. I don't know, 200 thousandths, 0.2.
So just that.
Yep. Okay, let's see if we'll do a door open. So you're ready to go now. You've set, you chose that, you chose that, you chose that. You're at a speed of 9, you want to 0 out the axis, you're ready to go now. So if you hit the cycle start button, I was a little bit on the safe side there. See how it's moving slowly over? It's because that speed is at 9.
And it still has the protector, so if you accidentally didn't push it back far enough, it would stop.
Right, it would stop. So you watch that voltmeter again. Yeah. Now it's going to come up, it's going to go to the other side.
Oh yeah, that's what you meant by where you put the whole job in.
Yeah.
So the 2.2 you took into account the very closest point of the electrode and the farthest point of
The whole distance.
Yeah, so it's not like just the inside.
Right.
Those are pretty good. It's still pretty close.
So when it gets done, it comes back to the center, and that display will 0 out because we said 0 out the axis.
No, or Y should be.
The Y should be, you know, if everything was indicated straight, you know, like we'd want to take an indicator and indicate that part in there straight. We don't know how straight the electrode is, but if the electrode was straight, we're in the center. Theoretical center right now.
In the axis, we don't really care about.
You don't really don't care about. But if this was a hole or a slot, you could do this function right here, the center find function. That's an external center find. This is an internal center find. So if you're going to go inside of a slot or a hole and you want to find the center of that hole with the electrode, you could do both axes at a time. In this case, it's going to do the X and the Y, and you would, it wants to know, see, you could leave these at 0 because this fast traverse means if you have you know, something that's very large that you're trying to find the center of, it would take a long time. You know what I mean? And that, you notice how slow it was when it came up and found that edge. So it's saying under fast traverse of the X, if you had a slot that was 3 inches long, you'd say, well, I don't want to go really slow for 3 inches. I want a fast traverse 2.5 inches. And that means it's going to go fast for, you know, 1.25 and then go into the edge find mode. Be careful with that. That's all I'll say, because if it's going fast, it can still bend an electrode or break an electrode, you know. It may take a little bit longer if you just leave it at 0, but it'll be safer that way. And then the same thing here, 0 the axis. Once it got done with the function, it would, in this case, since we're choosing both X and Y, it would 0 out X and Y. Questions? Get the home corner find routine. We're going to go over the move axis. If we wanted to move the machine other than using the hand pendant, we could go into move axis right now. And there's different modes you can move in. You can move in absolute, you can move in relative, you can move in machine coordinates. We're going to just stay in absolute. Absolute is, we're setting up the absolute right here. You know, when we 0 out the display, we're in the absolute mode. So if I wanted to move the machine to Z 1 inch right now, right? I just have to hit that cycle start button right now.
How do I go to the home position? Did we set one?
What's that?
How do I go to like the home position? Did we set one already? Is there a home? Was that the one where it was going back? If you ever wanted to? Is there a home?
Well, there's a home if you go home right there.
Yeah.
You know what I mean?
That was the position that was for.
Yeah, right. It's all the way up in the Z. It's over the X and it's over in the Y. You know, it's up in the Y that way, over in the X. So if you wanted to go home, you'd hit that button again to go back to home. Everybody all right with that? I'm gonna have everybody go through what we just did. Everybody should go through that at least once. We're gonna turn the machine on. We're gonna home the machine. We're gonna position the electrode over to the part. We're going to find the edge. We're going to do an outside center find so that everybody gets a feel for using the control. And using the first page, the machine just shut off. You know, obviously, really should be. You come up here. Are you sure you want to shut down the machine? We say okay. When you hear that, you're all right. So, I'm gonna hit the E-stop. So, do I have a victim from the audience to do this? Well, actually, we never zeroed out the X. We just did the y. We did the y and the z. So this is why y0 right now, it's just an x0 was the last, whoever set the last x0, that's where it was. And the z was, you know, obviously that's 6 inches down to here, right? 6.5 inches down.
Right.
So what I want you to do is just manually move the z down close to the top of that. I'm sorry. And remember, you have collision. If that button is lit, you have collision built in. So even if you come down fast and hit that part, it's going to stop. As long as it's electrically conductive. Black oxide, not so much.
I can use the fast, you know, get as
Yes, yeah, that's it. Yes, yes, yes.
I was gonna ask, for the X, could we have moved it to what we thought was a 0 and then changed it to
Yes,
0?
yes.
Or even for the Y, if it's not necessary.
To be perfect, yeah. You can just go to that, wherever you want to set 0, and just manually go in there and say, like I did, or I don't know if you did. Just hit the icon right now next to X and say 0.
Nice, so you can just do it.
Yeah.
You don't have to go through
Yeah, that's good, right there. So now, you go to the icon that says Edge Find, and again, you get the axes that you want to do an Edge Find in. In other words, which direction and which axis do you want to do the Edge Find in?
do the Z first.
Right, Z minus, right? You don't want to go Z plus, go Z minus, right? It's going to back up once it's done. 1 millimeter, that's the next to the slowest speed. 10 is the slowest. 1 is the fastest. Why they did that, I don't know. But and it's going to preset the Z to 0 when it hits the top.
Okay. So I just
Yep.
hit
Watch your voltmeter. See how it hits?
Z. Yeah.
Does it again? And it's like taking an average of those 3 hits. 4 hits. Sets a 0 and then backs up 39. So if you look underneath there, there's about 1 millimeter between the bottom of the electrode and the top of the part. It's,
Okay.
you know what I mean? When you put in there 2.2 like we did, it actually moved 1.1 over.
Can you use 2.2, right?
Yeah.
It's that's
0. Then you just reset 0. You know, if that's what you want to do, rather than using any of these functions right here. Couple other features right here. We want edge find. We talked about center find. I'll go back to spark alignment later when we actually get into the burn-in. The move axis. Other than, you know, you could use your hand pendant to move around, or again, use that move axis to move the electrode somewhere in the travel of the machine, and you could do it either, again, in absolute or relative. Now the difference between absolute and relative is, let's do it in the Z. Relative means incremental. In other words, every time I hit the button now, it's going to move up that number.
all right.
All right? Whereas if I say absolute, I keep on hitting that button, I'm at that number, right? It's not going anywhere. Absolute is in relation to a 0. Into a 0 you set. Relative is not. Relative is incremental. It moves, regardless of where the 0 is, it moves the amount you put in there. Okay, that's the difference, and then there's the machine coordinates. I don't really get into the machine coordinates. So that's move axis, corner find. Can't really do a corner here because I'm not. Corner find routine. You would position the electrode on a corner. So if this was my part, and this is my electrode, and I wanted to find this corner right here, I would come with the electrode somewhere off of that corner, both in X and the Y. And then I would choose, which one of these icons you think I would choose for this corner right here? That's correct. And then I have to give it a number or a traverse of the X. So I'm off of that corner by a certain amount. It needs to know how much do you want it to move in before it edge finds. Right? So it needs to know a value to move in before it edge finds in the X. I don't know, an inch. So that means that when it runs the routine, it's going to move in an inch in the X and do an edge find. If I say Y, it does the same. Does the same thing in Y. So it'll do that X, come back, go up into Y and edge find. So it's gonna set the theoretical corner of the electrode to the corner of the workpiece and call that 0. Okay, and you got obviously the 4 corners that you could edge find on. I don't use that function all that much because I like to work from the center of the workpiece, but that's just a preference on my part. And if you wanted to zero out all your X, Y, and Z, you can hit that. That zeroes out all 0 right there. Let me get out of there now. I have to go to another function for you. So that's right now. That's the setup page. Anything on this? You sure you're all good with the setup page right now? Because we're going to move on to the next.
So hold on a second.
All right.
So what is halfway?
Halfway is between 2 points. Like if you're moving between 2 points, like you set a 0 and then you move and you do another setup, it'll move halfway between those 2 points.
So different than center find somehow?
Do you have like an odd shaped part or something? Like a T-shape?
Well, if you do that, yeah, it's like 0 on axis. Like if you set a 0 already, it will all, when you're edge finding on that, it'll go halfway between those 2 points. Maybe I'm not explaining that very well.
Halfway between the 0 and the edge?
Right. You got that's why it's showing a 0 right there. And then you edge find again. It'll go halfway between those 2 points. I didn't explain that very well. But I don't use that function all that much. But one thing you have to be concerned about when you're indicating parts in. You're going to have to turn the collision prevention off because usually you use an indicator and unless you have a ruby tip stylus on your indicator, it's going to sense that. You know what I mean? So then you have to turn the collision off to move the machine. That's a little bit of a pain. Like when you're trying to straighten out a piece to make it straight or parallel with the x-axis, you're going to have to turn that off. You're going to find that out anyways. When you try to move the machine, it's going to say short circuit down here. All right. And so now we're going to move on to the next icon, which is the job creation page. This is how you're going to set up a job, and I'm going to right now use a feature on there to help you out, and that is called the automatic programming function. Okay? But the first thing that you have to do is create a job. Okay? And the way to do that is, let me go back. So I'm here, I come here, there is a program right there. What's it called? It's called example. If I want to see what's in my memory right now, I just hit where example is under job name, and it gives me a list of, I hate this. Gives me everything that's in memory right now. So if you wanted to go in and I am bad at this. If you wanted to take this FZ test, right? You say okay, and now it's right here.
Okay.
That actually, now that program is in memory. We're doing something with loops and compute loop. I don't know what that would be. Oh, they're doing a Z test, so they must be going and somebody in the factory actually created this. But anyways, I want to create a new job. So if I go into job name, you see this at the bottom here, I say new. And then what do you want to call that job? I'm going to just call it class. Okay? And I'm going to say complete at the bottom. And it's an empty job right now. It says class here, empty job, right? I want to go to the add function. When I hit the add function, here's everything that I could put in that program. Put all these things in the program, which we'll get to in a minute, but what I'm going to do right now is use something called automatic erosion programming. And I'm going to highlight that. I'm going to say OK. New screen comes up. It says process data. And it's in red. So it needs, when you see something in red, that means that you have not finished that part of the automatic erosion program. RA an inch. Okay, so the first thing that we have to choose is which direction do we want to erode it? Do we want to burn it? I could burn in any axes right now. Y positive, X positive, Y positive, X positive. You go to Z positive. But most times you're going to deal with Z negative. So that's why it defaulted to Z negative. But you can burn this direction. Burn this direction, you burn any direction you want. Machining target coordinates. What do you want to burn to, depth-wise? And again, when you edge bound, that's what it's going from. You know, when you set that 0 in the Z, how deep down do you want to burn? So, I don't know how deep, but I'm going to just click in there and I'm going to say, 200,000, Steve. RA. Yeah, surface finish, but you guys are, here's, for people that, like myself, like RMS value, most people know RMS values, so like an RA, a micro-inch, that's what they're looking for right here. So another in square inches, length times width. approximately, because then it knows how much power to use to burn. So you have to kind of do a calculation of the frontal surface area of your electrode on the part. So if I was burning this, I would just take the length times the width of that. So I'm just going to throw in a number of 0.5 or something.
So in the case of that dog bone there, it's burning inside and outside. I mean, leaving inside and outside. It'd be the width of that times the perimeter.
And yeah, you don't have to get crazy with it, but it needs to know somewhat close to that surface area, because you can spend a lot of time trying to figure out. Of course, you can go to a computer and figure it out too, but yes, that's right. The dog bone
So
is
it's the area that's actually in contact with the road.
the contact area. That's exactly what it
I was
is.
about to ask, so if it is to be...
It'll be tiny. It'll be very small.
So there's one that says tiny there.
Well, you put in there like 0.01 or something like that. You know, I mean that's real tiny.
So is
You
it
put
more
it-
of a perimeter value or an area value?
It's more of an area value. I mean, it's area of, you know, it's the contact area. You know, for a diameter, it's pi r squared, but isn't it?
Hey,
Yep, pi r squared.
Yeah, and then
So if you had that hollowed out one, would be big pi or
so it's not the
pi big
actual
r
like
squared.
perimeter that's touching the actual entire area.
Okay, got that.
so we're just throwing in there a number, and then it needs to know what you're burning with and what you're burning into.
Oh, okay.
In this case, it says copper to steel, but you have a couple of choices here. A normal graphite to steel and a fine graphite to steel. What's the difference? It's basically the porosity, the density of the graphite. The more dense, less porous is a finer graphite. It's going to hold up better. It's going to give you better surface finish. It's more expensive. It's like brand name, they call it Poco, if you're familiar with Poco graphite, like a Poco 3. That's a finer graphite. Again, it'll hold up better, give you better detail, give you better surface finish. Normal graphite, let me go back, less dense, more porous, less expensive, but it wears a little bit more. I can't tell you which one to burn with, but I can tell you the difference. And then there's, if you're burning carbide as your workpiece material, you could use copper tungsten to carbide. And then there's copper to carbide. And basically copper to steel. So you got like five choices to choose from. So we're going to just choose that fine graphite. For now, we're going to deal with the default database. In other words, in the machine, where's all my settings? Aren't my settings in here? I thought all my settings in here. Maybe not. Maybe they're in the other book. Anyways, there's a database of power settings in the machine, and you can actually create your own database. In other words, change settings to your, so that when it calls up your change settings. Otherwise, it's going to just pull up what's existing in the machine. So you can go in there, you can massage the default database and rename it to whatever, Jim or whatever you want to call it. But right for now, we're just going to use default. The strategy, there's three choices on strategy: minimum wear, maximum removal, and standard values. The difference between those are minimum wear settings result in less wear on the electrode, but there is slower burning technology. It'll take longer for the burn to take place with minimum wear settings. but the electrode will last longer. Maximum removal burns the fastest, but the electrode wears fastest. And then there's standard values, which is in between those two. It's in between minimum wear and maximum removal. All right? So I'm just going to use standard values for now, just to show you that. So we answered these questions. Which direction are we going in? What depth? What finish? How big is the electrode, basically? What electrode workpiece combination we had, and what strategy we had. The final thing is, how much did we make the electrode undersize by? From final size. And that's a total amount. In other words, if your pocket is an inch and you made the electrode 990, that's 10 thousandths under. It's not per side, it's the total amount undersize you've made it. So let's say I made the electrode 5 under a side, 5 thousandths under a side. So it's 10 thousandths overall. I say okay. I answered those questions there. Right now we're not, we have a single erosion point at X0, Y0, Z0. Okay, we're going to leave it there, right? We're not doing an array, we're not doing circular. A circular array, we could go to that a little bit later, but right now it's just a single point, right? And then finally, something that I referred to earlier is an orbit. On a manual machine, you don't have the ability to orbit. So you make your electrode to a certain size, you burn it, with that overcut, that's what you got, right? With this machine, it has the ability to translate. So if you're burning in the Z, you could do a circular type of orbit, you could do a vector orbit. So right for now, we're going to just do the free orbit. Don't worry about the servo orbit. I'll get to that a little bit later. And then the shape. You see the shape that you got here? Of the type of orbit you could do. You could do a circular type of orbit. You could do a diamond shaped type of orbit. You could do a vector, but the vector is straight out, straight, which leaves material in corners. Or you could do a 45, which would shoot out like this, that. So most times you're going to either use, in my opinion, you're going to use the circular, or you're going to use that one. The reason, the differences are between this is that when you use a circular orbit, so you plunge down and you do this with the electrode, what are you doing to these corners? If they're square corners, if they're sharp corners, and you're doing this, you're putting radiuses in the corners. And the radiuses will be as big as how much you're orbiting, which not in this case is that big, it's only 5 thousandths. But still, if you need to maintain sharp corners, you're going to probably want to use that type of orbit. All right, so we don't care about the shape right now, or we're going to just do a circular. The radius it put in, how much it moves out per side, 5 thousandths, because we told it on a previous page. The electrode was 10 total, so 5 per side. That's why it gave me, it automatically put in a 5 thousandths radius, how much it's going to move out per side. You don't have to worry about that. So when we answered the free orbit and the circular orbit, we're basically done here. Okay, if I say okay, just wrote my program. And you notice that it says start of automatic erosion program steps, move to work point 1, which is that X0, Y0, and then it does a series of erosions. It figured out by how, you know, how much the surface area is, how much undersized the electrode is that you told it, and the final finish, how many steps it needed to get from rough to finish. So what it's going to do is it's going to rough down, it's going to change settings.